Welcome. In this lesson, we're going to take a look at the insertion sort algorithm. Let's get started. The learning goal for today is that you can explain the insertion sort algorithm and use it to solve problems. Just as we did with selection sort, our objective today is to rearrange the data in the array numerically from least to greatest. Remember that for sorting, there's different strategies. We've already looked at selection sort, and now we're going to look at a different technique called insertion sort. To understand how insertion sort works, we need to imagine that our list is broken into two parts. A part that is already sorted, that will be blue, and a part that is unsorted, which will be white. Now the blue part is only one element, and by definition, a list of one element is sorted. We'll begin the insertion sort process by taking the first element in the unsorted part of the list, which in this case is a 4. Next, we're going to take the elements in the sorted part of the list, the blue part, and shift them until we find the correct insertion spot for the 4. Since 4 comes before the 8, we're going to have to shift the 8 to the right. Finally, we'll take that 4 and insert it in the spot we created. We're now going to repeat the process we just started by, again, taking the first item in the unsorted part of the list, which is a 9. Since 9 is already in the correct place, we can go ahead and add it to our sorted list without actually doing any shifting. The first item in the unsorted part of the list is now -2. Now we'll shift all the sorted elements to the right until we find the correct insertion spot for the -2. Since -2 is the smallest element in the list, all of the sorted elements will shift. And once we're done shifting, we'll insert the -2 into its spot. Now the first item in the unsorted list is a 1. Again, we'll shift all of the sorted elements to the right until we find the correct insertion spot. 1 goes in the middle of the list, so it's just the 4, 8, and 9 that will shift. And then we'll insert the 1 into its spot. Eventually, we'll end up at a point where the unsorted list only has one element left, in this case a 4. As we've done previously, we're going to have to shift elements to the right until we find the correct insertion spot for the 4. In this case, the 8 and 9 will have to shift. Finally, we'll insert the 4 into its spot, and we've completed our insertion sort. In order to implement insertion sort in the code, we're going to need to take on 3 steps. The first is that we have to go through every single element in the unsorted part of our list, and for each of those, we have to shift all of the sorted elements to create an insertion spot. The final step, of course, is actually inserting the element. Traversing each unsorted element is basically like doing a normal traversal. The only difference is that when we start our loop index, we start it at 1. And we start it at index 1 because remember, index 0 in our list is already considered sorted. So when we're talking about the unsorted elements, those start at index 1. Now that we're looping through the unsorted part of our array, we need to figure out how we're going to shift the sorted elements. Shifting the sorted elements into place is definitely the most complex part of insertion sort, and so we want to walk through that step by step to get our heads wrapped around it. For the purposes of this example, let's assume that we're almost done with insertion sort, that we just have to insert the very last element at index 5. So the first thing we'll do is we're going to define a variable toInsert, and toInsert is going to hold the item that we're trying to insert. In this case, it's the array at index 5, which is a 0. The next thing that we are going to do is we are going to define a new variable called sortedIndex and set it to index -1. So index is the spot of the element we're trying to insert. SortedIndex is going to start 1 less than that, and its job is basically going to be to figure out where the insertion spot is. Now we encounter a loop, and the loop says that we are going to keep going as long as the sorted index is greater than or equal to 0, and 4 is greater than or equal to 0, and also while the array at that spot, 9, is greater than the number we're trying to insert. And since 9 is greater than 0, we are going to enter the loop. and the loop is going to do the shifting process. And there's two lines of code to do in the loop. The first one says we're going to go to spot sorted index plus 1. So that's right here. And we're going to set it equal to spot sorted index. So basically, we're going to take the 0 and we're going to replace it with a 9. And then the second line says we're going to do sorted index minus minus. So sorted index was a 4, and now it's a 3. And we hit the end of our loop. So we go back to the top of the loop, of course, and we check to see if we need to run it again. So we check to see if sorted index is greater than or equal to 0, and it is. And also, is the element there, 8, still bigger than what we're trying to insert? And it is. So we're going to do this shifting process again. So keep in mind, we're going to the array at spot sorted index plus 1, and we're going to set it equal to the previous spot sorted index. And then the next step will be to do sorted index minus minus. So sorted index was a 3, and now it's a 2. So again, we've hit the bottom of our loop, so we need to go back to the top and see, is sorted index still greater than or equal to 0? Yes. And is the element there, 4, still greater than what we're trying to insert? Yes. So again, we do this shifting process, and we'll go to sorted index plus 1, set it equal to sorted index, and the 4 shifts. And we'll say sorted index minus minus. So sorted index was a 2, and now it becomes a 1. And again, back to the top of the loop. And we will check to see if sorted index is still greater than or equal to 0, and it is. And also to check to see if the element there is still bigger than what we're trying to insert, and it is. So once again, we'll shift that 1 over to the right, and we'll do sorted index minus minus. Now we'll check to see if we need to go through the loop again. So at the top, we're going to check to see if sorted index is greater than or equal to 0. It's equal to 0, so we're okay. But now the second condition is going to fail because the array at this spot is no longer bigger than to insert. And so at this point, we're done and we exit the loop. The last step will be to insert the element. And for that, we're only going to need one line of code. We are going to go to our array, and we're going to go to spot sorted index plus 1. So that's going to be right here, because sorted index ended up at 0. And we're going to set that spot equal to the element we want to insert. And voila, we are done with the insertion process. Time for an understanding check. Here we have the complete code to insertion sort. It sorts the numbers from smallest to biggest. What would we have to change if we wanted to sort the numbers from biggest to smallest? Pause the video, and when you're ready, we'll check out the answer. In order to sort from largest to smallest, all we would have to do is change our greater than sign to a less than sign, right here in the while loop. This is the only spot where elements of the array actually get compared, so it's the only spot we have to change if we want to change the sorting order. Now that you've seen this lesson, you should be able to explain the insertion sort algorithm and use it to solve problems.